Welcome back to the 3.4 notes. We're talking about interquartile range here. Part B asks us to determine and interpret the interquartile range. We actually already wrote that on the front, but now we have the official definition and formula right here, glued in. So the IQR is going to be my, just as it says in the box, Q3 minus Q1, which in this case is just 21 minus 7, or 14. My IQR here is 14. That's right, Q3 minus Q1. Alia, can you read the interpretation, please?
Yes. The length of stay in the middle 50% of patients spans roughly 14 days.
Nice. Next, we're going to put in our 5-number summary. Little slip here. As we mentioned on the front, this is just the formal definition. The 5-number summary of a data set is the minimum, Q1, Q2, Q3, and the maximum. The minimum of my data set was 2, and the maximum of my data set was 55. For now. We're going to talk about outliers in a minute. Might change. But for now, my 5-number summary is going to be 2. 7 is my Q1, so that's my next number. 18 is my Q2. 21 is my Q3. And 55 is my max. The interpretation for that, will you read that, Toby?
Forward quarter has the greatest variation. The middle 50% has the most variation, and the first quarter has the least variation.
Excellent, thanks. So you can see, if I'm looking at my upper quarter of my data set, that's between 21 and 55, that's got a 34-point variation, 34-point spread, versus the middle 50% there had that, was the IQR, was 14-point spread, and then the lower is just a 7 minus 2, 5-point spread. So this interpretation just is referencing, again, a generalization of what's going on in this data set. In this next section, you're going to put two things. So leave some space. We're doing the lower and upper limits as well as the orange arrow. Bless you. So my definition box here talks about identifying lower and upper limits. The lower limit would be just taking the Q1 and subtracting 1.5 times the IQR. The upper limit is going to be taking Q3 and adding 1.5 times the IQR. Those kind of set the bounds on where we would expect the data to lie. Okay, if it's outside of the lower and upper limit, we have a special name for that. Outliers. Will you read outliers, the definition there for us, please, Jade? It's in the orange arrows. things. Right, so if we're like taking a look at average income or the income comparison in the US, and we include Bill Gates, that would be outside of where the normal range of our data set would be. So we're going to calculate potential outliers here with our data set. I'm going to take the lower limit, which is Q1 minus 1.5 times the IQR. Lower limit, that looks terrible, doesn't it? I'm sorry. Lower limit. I don't know what just happened with my handwriting. Lower limit. Okay, Q1 minus 1.5 times the IQR. It's also written right here. Q1 is 7, so I'm going to do 7 minus 1.5 times the IQR, 14, which is going to give me negative 14. I don't have any observations south of 0 in this data set, so I definitely don't have any outliers beyond my lower limit. So we're good on that end. So we're going to calculate the upper limit next, which is Q3 plus 1.5 times the IQR. Q3 was 21, so we do 21 plus 1.5 times 14. What do we get when we did that one? Anyone? 42, well done. Thanks for verifying. So we're looking at 42 as our upper limit here, and we go up and we see, oh, there's a 55. 55 is beyond 42, so this number is called a what? Outlier, that's right. 55 is an outlier. 55 is an outlier, and the number that is within the range, just inside the upper limit, just before the outlier, has its own special name. It's called an adjacent value, and you have that written on these blue arrows, adjacent values. They don't really fit on this page, unfortunately. We're going to stick them on the next page, but we're going to call 24. So 24, let's label that, is an adjacent value. The definition for adjacent value is the most extreme observations that lie within the lower and upper limits. The most extreme values that lie within the lower and upper limits. So what would be the adjacent value on the lower end of this data set? 2, that's right. Just to clarify, it says that on the other side, the adjacent values are the upper and lower limit when a data set has no potential outliers. So so this is the adjacent. We're going to turn it over, we're going to stick in our last thing here, and we're going to stick in our arrows. I think we're going to get there just in the nick of time. I'm going to speed talk here, so if you need to slow me down on my YouTube channel, you can do that. Or press pause where needed. I'm going to move along at a rapid pace here. When you do the editing, you can put me in slow-mo here. This is what it looks like to speed round glue stick. It's not a pretty sight. Okay. Construct and interpret a box plot. Here goes. Step 1, determine the quartiles. Check, we did that. Determine the potential outliers and adjacent values. We did that. Number 3, haven't done that. Draw a horizontal axis. I'm going to go ahead and draw a horizontal axis here. My minimum and my maximum, I'm just going to slightly below my minimum, so I'm going to go down to 0, and slightly above my maximum, I'm going to go up to 60. 30 right there in the middle, with a 10 and a 20 down here. I'm going to sneak a 5 and a 15 and a 25 here. 30, 40, 50, 35 here, 45, and 55. And then above the axis, it says mark the quartiles and the adjacent values with vertical lines. So my quartiles and my adjacent values, we're going to go with, essentially these are my 5-number summary. Two, 7, 18, 21, 2, 7, 18, 21. I'm also going to include 24 as my adjacent value as well as 55 as my outlier. 24 and 55. 55 again, we identified as an outlier. Vertical lines go in the place of 2, 7, 18, 21, and 24. Sneak that guy in. Then it says connect the quartiles. The quartiles, remember, were the middle 3. Connect those with horizontal lines to make a box. And then connect the box to the adjacent values here. Ta-da! Now I have my box plot, also known as a box and whisker plot. It's been a while, huh? 55 gets a little asterisk out here. It's my outlier. The interpretation is that the potential outlying observation falls far from the rest of the data. The other stays vary from 2 to 24 days. The majority of the stays were between 7 and 21 days. Box plots are good for comparing data sets, and you'll see this in your math Excel, so I wanted to be sure and give you an example. You can see these 2 box plots, and there's a lot that is similar within those 2 box plots. Their middles are close to the same. However, there is less variation in the weight loss of group 1 than group 2. There's less variation. So you can see that these vertical lines are closer in than in the second group. So group 1 has less variation than group 2. This concludes our notes for 3.4. Like and subscribe.